Ready? Okay, all right. Good afternoon, everyone. My name is Mike Moore. I work for Nokia. I'm the regional product manager for Nokia's AirFrame data center product line. It includes servers, switches, storage, racks, fully integrated systems, and two of our reference platforms, openRack and openEDGE, are both OCP contributed platforms. Or should I say from openRack at least, we've contributed two, and then with openEDGE, we actually were the seed contributor. And so Nokia, we are a platinum member of OCP. We've been so since we joined back in 2016. We do hold 2 chairs, and actually this slide is a little dated. We actually now have a position in the incubation committee within OCP as well. Going back to our last summit, just to show that we are very active in the community, we contributed our openEDGE chassis, which I'll be talking about in more detail here today, our openEDGE server, and then we made some continuing kind of telco optimized contributions to openRack in the form of the server design, and then also a seismic kit. Many of our telco operators, especially on the coasts and around the Pacific Rim, require full NEBS seismic zone 4 certification. And so we developed really a snap-on or a bolt-on kit that goes on the rack that allows it to to tolerate seismic events. And so openEDGE itself, this is a platform that was designed from the ground up to be deployed to the edge. The form factor itself, the 19-inch 3U form factor, the 430 millimeter deep form factor is really designed around a wireless baseband unit, like a 3G, 4G, 5G baseband unit. And the idea of that was that that form factor has already been optimized for far edge deployments, out to and including the cell tower, and so that seemed like a natural form factor for us to put an edge device around. It is 3U in height. It can hold up to 5 1U servers or 2 2U servers and a 1U server. We took many of the what we kind of thought were best practices from openRack version 2, and in the form of a fully front-operated platform. All the cabling, power, grounding, everything is front-oriented. Which really, when you're talking about going out to an edge site, this allows you to locate the device, up to, not right up to, but pretty close up to a wall, and where you have no rear maintenance requirements at all. It really allows you to optimize the the edge space that you're trying to install into. But even though we're deploying this to the edge, where cost is certainly a key factor, we still wanted to make it a high availability device. So there are no single points of failure, SPOFs. We do have redundant fans, redundant power supplies. We test all of our servers for NEBS certification, assuming one of the fans has failed. So to make sure that we can pass with fan failures in place. And we also support both front to back and back to front. So the dimensions, the power, we support various power that you'll find out in the far edge, both 110, 220, and negative 48 volt DC. We can go up to 400 watts per sled, 700 watts for a 2U. All of our management is also done through the RMC, the rack management controller, which is, I'm going to step into the dark here for a second, which is actually this device right here. The rack management controller itself is really the gateway to all of the BMCs in the chassis itself. And one of the things we realized that it was especially important, port count out at the edge. When you're in a data center and you have the room for an extra maintenance switch, you can just cable all the servers individually to a separate switch, but you might not necessarily have that luxury out at the edge. And so we were able to basically condense what would be 6 maintenance cables down to a single cable, and actually had it set up so we can daisy chain multiple chassis together and multiple RMCs together to represent the entire maintenance network from a single port. Now, I know you're probably thinking, well, that is a single point of failure. Yes, it is, but you don't necessarily need access to the maintenance network to have your servers run steady state. And you still have kind of in-band methods of monitoring and controlling your servers, even outside of the BMC. Okay. So, where could it be used beyond 5G? Yes, so 5G, we definitely had the virtual. Oh yeah, absolutely. So doing much of the layer 1, layer 2 real-time processing, like for the virtual DUs in 5G, what we call our vRAN 2.0, which is a 5G-based vRAN. We had a vRAN 1.0, which was slightly flipped. The real-time processing was done in dedicated hardware, and the non-real-time layer 2, layer 3 was done in openEDGE. That is an application for this. The servers do support acceleration as well, in terms of FPGA cards or GPUs. Actually, the 2U can support up to a full height, full width, full height, full length, double width GPU. So we did realize that as we deploy to the edge, some very powerful focused acceleration may be required as well. And so we designed that into the product. As far as other applications go, latency and bandwidth sensitive applications such as IoT, MEC, different things that require like the upcoming ULRCC, ultra low latency communications. It's a evolving 5G spec, that could certainly take advantage of the, of having focused compute close to the edge. Yes. So actually, this turns out to be a very good platform. Perhaps not with the higher end processors that we spec out for 5G, but maybe a lower end, 12 core, 16 core processor works very well in like a CEBA environment or virtual OLT type of environment. The environmental specs, which I don't think I go into in detail here, we operate up to 45C. -5 to +45C, and with short-term durations or tolerances to 55C. So it's meant to really even go into enclosures that can be deployed outside. The virtualized and distributed IP edge, this is really critical to enabling MEC, especially when you take the distributed bearer plane and deploy that out toward the edge. That in addition enables a lot of MEC-based applications to be deployed to the edge as well. And then the last one, the public-private cloud. We did have an idea at one time that we could actually offer this platform as a platform to host public cloud deployments as well. As long as we were deploying this to the edge for vRAN, a public cloud provider could piggyback on top of this. That, due to certain customization of public cloud infrastructure, that really didn't become an option. But still, there's a very much a hybrid cloud opportunity, multi-tenant hybrid cloud opportunity associated with this, moving this compute to the edge. So, where we've been at on this openEDGE journey so far, it was last April at the NFV World Congress where we first announced the platform. We then started our planning at that time for our contribution to OCP. We had a working demo a year ago at the Amsterdam Summit, and we released our draft specifications. Commercial availability was achieved at the end of the fourth quarter. First commercial contracts came soon after that. We then started to finalize the design, and we had a well-attended workshop out in Mountain View, just down the street, where we finalized the chassis specification, and it was granted an accepted status. Soon after that, WIWYNN actually had a very public announcement that they were going to be adopting openEDGE, and I'm going to show you here in just a little bit what they've brought to the openEDGE community, and in the form of chassis and server blades. And then, more recently, we've really seen an acceleration of adoption of openEDGE in the form of an ARM-based Sled, a battery backup unit under development, a second hardware vendor announcing both chassis and servers, and then more recently, a power supply vendor is also wanting to create OCP-accepted power supply specs. So this is our family right now, including Nokia, WIWYNN, Inventus Power, ARM Marvell, and soon to be another company joining the openEDGE OCP community will be they're doing the ARM processor. Yes. ARM obviously has the IP. Marvell's doing the processor, and then there's a third company that. Is it ARM or ThunderX? I'll get to it here in just a second. I really want to know. Yeah, I've got it here in a couple of slides. And then Flex and Asus, round out the community at this point. So this is the Nokia chassis. I kind of went over the specs earlier, so I won't dwell on those. But it's up to 2,000 watts per chassis. Up to 5 one-use sleds, bidirectional airflow, a very simple backplane design. Basically, it's power distribution, which is 12 volts on the backplane. A very simple unmanaged layer 2 switch in the RMC. Gives gigabit Ethernet access to all the BMCs. We've got an SM bus as really sort of to communicate with the power supplies, but then as a backup communication path for sleds that may not have Ethernet management connectivity, and then just some really simple control. The idea really behind this was to create a chassis that would last for multiple generations of servers. And I know that I was having a conversation at lunch about ATCA, right? And I went through 3 generations of ATCA, and every generation they promised that the next generation backplane would be Ethernet speed would be backwards compatible with the one we currently had. All right, so we started with 1 gig. When 10 gig came along, we needed a new chassis. When 40 gig came along, we needed a new chassis. So we did learn our lessons from that and made the decision that we were not going to put any sort of high-speed communication backplane in this. Well, this actually doesn't have a filter on it. We've actually I took some pictures at another conference this week of a filter design that I thought would be a really good option for this, but I was really only considering front to back. So back to front is a good question for that. Typically for our outdoor enclosures, we use sealed containers, with heat exchangers on it, and so we don't have to worry about filtration. This currently doesn't have. I can't remember if it's IP60 or IP65, the dust specification. That this currently isn't rated for that. Thanks. Okay, but the fans themselves. it's really just the orientation of how they're installed that determines. We don't have programmable, fans, although that'd be nice to have. So the 1U, 2U chassis, Sled, the motherboard itself is exactly the same for the two, and it's really just the riser card that differentiates it. Right, the 1U is really more focused on compute with some limited acceleration. We can do up to full height, half length cards, and we do have a power extension on there for some of the FPGA cards that exceed 75 watts. And then the 2U, which has slightly larger fans, a little better CFM with those fans. They're designed for up to the full height, full length, double width cards. Okay. But I don't want to dwell too much on Nokia. WIWYNN has come along and they've done an OCP accepted chassis design, and they've done their own sleds. In a way, I do like some of the designs that they put into this sled as well. They offer two 15mm NVMEs, which is, I think, a really good option. And, with the same amount of connectivity, one OCP 2.0 MES and one up to full height, half length card. And so it's fully compatible with the OCP specification. As a matter of fact, at the OCP Regional Summit in Amsterdam, coming up here in 2 weeks, we will have an independent demo running with Nokia and WIWYNN products interoperating in each other's chassis. So their Sled themselves, they're going with also with a 1U and 2U half-width version. They're also looking at doing a 1U full width. I assume a dual socket, maybe in their future plans. In addition to that, and these are also all Intel Cascade Lake based processors. So the ASUS spec, again, the chassis will be compatible, interchangeable with any of the other vendors that are out there. And to me, this is important because we can sit and we can preach about all the benefits of open hardware, right? But if there's only one vendor that's actually producing that hardware, how open is it really? If Nokia contributed openEDGE and we were the only ones that ever produced it, we could call it open, but in reality, you would be vendor locked if you were to purchase from us, right? With something like this now gives the customer options, right? They can go out and they can purchase, largely similar, identical chassis, and then similar sleds. So it gives them a level of freedom that they don't typically get from other form factors. ASUS themselves, they're actually doing a Xeon D based platform, or Sled, which I think is fantastic. That they're going to produce in 4, 8, and 16 core versions. That'll be their initial pass at it, and I'm glad that they've elected to not go with kind of I don't mean it to sound the wrong way, but a Me Too approach on Cascade Lake, like Nokia and WIWYNN did. So I'm glad to see a little more differentiation coming in the Sled offerings. And speaking of differentiation, here's another one. This is the Thunder X2. Right, so this is a blade that's in development by ARM, Marvell, and I guess I can say their name. It's also Ampere. Ampere is actually working on joining the OCP the Open Compute project right now. Yeah, so this will be an ARM-based sled, which I think is another great differentiator to option to have with openEDGE. similar types of memory support, support for PCI expansion cards. Everything's still, Gen 3 at this point, and then, some limited storage. One of the things that was released with the spec, the chassis spec, was there was an extra power connector included in slot 1, which is the lower right-hand slot. On the left hand, you have the redundant power supplies and the rack management controller. But on the right side, we have an opportunity for a battery backup unit. Well, Inventus has stepped in and filled that with a battery backup option that will supply between 3 to 5 minutes of continuous power. And that's actually 3 to 5 minutes at 5 years. Initially, obviously, the discharge is going to be, your time is going to be a little bit better. Still staying within all the specs of the specification itself. And this is also something that they'll have. This is one of the examples I was talking about. They won't have a BMC on there, but they'll have an SM bus connection that will allow it to interface with the RMC. And then this battery backup will also charge off of the 12-volt power on the backplane. And then a recent addition was Flextronics. Flextronics has actually come in and they've offered to contribute their power supplies. So they'll be contributing, initially 2,000-watt power supplies in both AC and DC flavors, negative 48-volt DC. And the way all these products that I've shown so far, I've shown with their permission, with the permission of each one of the companies, and these will be on display at the regional summit in 2 weeks. Right? So these, it's not just not just slideware. That these are actually actual products that are in development. So in summary, openEDGE is a platform that was designed for the edge and far edge. In particular, vRAN, MEC, IoT, URLCC types of applications. We're very active within the Open Compute project to solicit additional vendors, obviously additional customers. Use this as a foundation or a reference platform for for additional innovation and additional designs. All the specifications we have, all the meeting notes, minutes, recordings can all be found on on opencompute.org under the openEDGE. Well, it's actually the openEDGE sub-project. It's a project underneath the telco project, and we're definitely looking for additional vendors and customers to drive innovation in this space.
I thought you talked about two different platforms, openEDGE and something called Air.
Oh, so AirFrame, yeah, AirFrame. I'm sorry, AirFrame, yeah, that was kind of part of my introduction. That's the name of the data center product line that Nokia produces.
So that has nothing to do with openEDGE. That's a separate
Right. No, right? If we go back to, these slides. So
yeah, AirFrame chassis overview.
This is Nokia's
like a completely different product.
Yeah, this is Nokia's openEDGE contribution.
Okay, so are you saying that AirFrame is Nokia's product that implements the openEDGE reference design?
You got it. Exactly.
Is that what you're saying?
Yes. Exactly.
And this is a compute server?
Yes.
So,
yeah,
okay.
It's right now it supports a 1U and 2U compute
Why is
platform.
Nokia in that business? Nokia has never been in the computer business before in all its previous subsidiaries.
Well,
now you're in the computer business?
Not necessarily true. Nokia's been in the.
We'll have to argue about that.
Okay, sure. Here's my argument. We've been in the telco infrastructure business for over 30 years. We've been producing Intel-based reference platforms for over 30 years, right? But everything we've done has been custom telco solutions, right? So as we've made this
in the past, custom telco computers.
Yeah.
Okay, I was not
custom
aware of that.
telco compute solutions. right? DX200 being one example. All of our baseband units. Another example. Our ATCA-based solutions. Being another example. And so, as the industry has moved from purpose-built hardware to a virtualized environment, we've simply refocused our engineering efforts.
So you refocused, and now you made a general-purpose compute server, whereas before they were specialized computing engines for telcos.
Yeah.
Is that what you're saying?
Exactly.
Okay, go back to the summary slide then.
Okay.
Thank you for that clarification.
Yeah, no, not a problem.
Very important, because I thought they were two completely different open hardware designs.
No.
So
Yeah, go
by
ahead.
releasing, I'm curious as to the motivation for why you did openEDGE, particularly as a 3G, 4G, 5G base station use case, because now you're in competition with yourself. It's almost like self-sabotage.
Well, so...
Because you're releasing this to ODMs, they're going to undercut you, and now your purpose-built base station, 3G, 4G, 5G, isn't going to be competitive.
Well, no, there's also the saying, a rising tide lifts all boats, right? So...
And that's your company's motivation and strategy?
No, but the more as we open this compute platform and offer customers a non-vendor lock-in solution, we won't win them all, but I guarantee you that if we were the only ones offering this, we wouldn't win as many.
Infrastructure enable a good supply chain that it's actually easier for companies like Nokia that's selling a solution. It's easier for them to sell that solution based on open hardware standards. Well, yeah, but at the end of the day, they're not going to, it's all the same hardware. And so they're making their money on their value add set of services that run on top of it.
Are you going to use openEDGE in your 3G, 4G, 5G base station?
Yes, absolutely. Yeah, that was actually an announcement that came out in Mobile World Congress this year. It's actually called the AirScale all-in-cloud platform. And it's a virtual RAN-based platform that is based on openEDGE.
It's not much different on the server side as well. And we see similar
So even though other
evolution.
companies would compete with you, you're expanding the overall market.
Exactly. Yeah, any other questions?
So in the interest of time, we're kind of on the edge of building.
I can go. I got next. I'm firmware. I can go quickly. So.
Question I had is, so currently this is obviously compute focused. Interested to know if there's any conversations going on with the network equipment vendors, the edge cores of the world, etc. I don't know, like an edge core sled that would go into an openEDGE chassis.
Yes, there is. There is work going on. Conversations with bringing in switching as an integrated unit. I think that, obviously the compute was the first need, but networking is definitely what we need. What we need to fill out this platform. This is a community specification now. Right, so it's really open to how the community wishes to drive it. From a Nokia perspective, we very much like the approach that was taken with OpenRack. We've adopted that form factor for our denser central office compute solutions, and we think the simplified backplane, all front oriented maintenance solution is really gives you the best value for your dollar, and also lowers your overall TCO.
So if I replay conversations in OpenRack 6 years ago, a lot of conversation around data and control planes on the back of OpenRack, and in the end, there was fought with problems and issues and upgradability, and we didn't prevent anything, but the community did not go in that direction, and it's survived quite well and prospered well, and the interconnects are all done on the front now. And that conversation, I probably died 4 years ago, and hasn't been brought up.